So in this video I'm going to show you two very famous ways of solving a quadratic formula, and surprisingly the two are very similar, but when you look at them they don't look similar. So first of all we're going to look at the quadratic. So it's always in the form of ax squared plus bx plus c is 0, where a is not 0 and b and c are basically real numbers. Okay, they can be anything from -2 to -4 to +6, whatever you want. They can be anything, and it can also be 0. Okay, so how do we go about solving this quadratic? Well, first of all, we need to know that a is not 0. So this term here, if that was 0, we'd just be left with bx plus c, which would be a linear term, in which case it'd be very easy to solve. So ax squared plus bx plus c. Okay, where do we start? Okay, so we need to solve for x. So basically all we need to find out is what x is. So x equals, that's what we're looking for. So we need to get these two terms together without the c term. So how do we go about that? So first of all, what we can do is we can divide everything by a. So if we divide everything by a, we end up with x squared, so let's put that here. So we end up with x squared plus b over a x plus c over a equals 0. Okay, right, now what do we do next? So next what we need to do is we could complete the square. So let's put this here, complete the square. So how do we complete the square of this one? So we need an x here and the x to disappear from here. So we need something in the form of x plus and then b over a squared plus c over a, that's just an a, equals 0. Now this is not complete yet, because now what we've done is we've changed the value of all this. So if we do b over a and FOIL that out, we'll get 2b over a. So we need to put a 2 on the bottom here. So there's a 2a. And then we're also going to need to subtract something, because when we FOIL this out, we'll get x squared plus b over a x. And then we will also have this term squared. So to correct that, we need to subtract it. So let's just give ourselves a bit more room. Plus c over a, and then now what we do is here we'll subtract b over 2a squared. Just about fitted that in, I think. Okay, right, let's simplify that up a little bit more, just make it a little bit more readable. So x plus b over 2a squared. Now let's square this up and see what it looks like. So we've got minus b squared, that's the b squared, and then 2a squared is 4a squared, plus c over a equals 0. Okay, so this is our x term, so we got that within these brackets. This doesn't involve x. So now what we can do is get everything over to the other side. So we've got x plus b over 2a squared equals b squared over 4a squared minus, flick this over, we'll get a minus c over a. Okay, right, let's do something with this just to make this look as one fraction. So this, what we need to do, if we multiply this by 4a and then 4a, we'll get denominator the same. So then we'll end up with b squared minus 4ac over 4a squared, and that will equal x plus b over 2a squared. All right, okay, now let's see if we can get this x out of this squared term. So how to do that? We just take the square root of both sides. So square root of that, square root of that. that then we'll end up with square root, so that we technically got a half there, or we got a 2, but it's to the power of a half. So what we can do is that and that will cross out. So x plus b over 2a equals, okay, so what we could say is we could say square root of the top divided by square root of the bottom. Alright, so then we've got square root b squared minus 4ac over 4a squared. What's the square root of that? Well, the square root of 4 is 2. Square root of a squared is just a. So that's over 2a. Okay, and then what we need here is, because we don't know if it's the plus or the negative versions, we need a plus or a minus here. Okay, so now what we're going to do, get the x on its own, take the b over 2a over there. So x equals minus b over 2a plus or minus square root b squared minus 4ac over 2a. Okay, right, now we can simplify this up a lot more now. We've got the 2a and the 2a, so these can become one fraction with the plus or minus in the numerator and the minus b in the numerator and this radical in the numerator. So then we end up with x equals minus b plus or minus square root b squared minus 4ac all over 2a. And then we know what this looks like. This is the very famous quadratic formula. That's how we've derived that. Now if we look back here, what we've got here, this is completing the square, which is also another way. So you can see now that both methods are very, very similar. So to complete the square for ax squared plus bx plus c equals 0, to complete the square, the general formula for completing the square is just going to be x plus b over 2a squared minus b squared over 4a squared plus c over a equals 0, which if we look further down here, we can go to here and use this part and basically simplify that up to x plus b over 2a squared, and then the b squared minus 4ac. Well, on this side, because on the other side it would be minus b squared plus 4ac over over 4a squared. Put that right, 4a squared equals 0. And if you use this formula, that will solve for completing the square on any quadratic of this form. Okay, there we go. So quadratic formula and complete the square.